Okay, let's talk about 3 ways to prevent mapping explosion in Elasticsearch. Um, I would like to take a practical approach to this video. I will um, actually make an example. We'll start working on an example in Elastic Cloud, and then I'm going to talk about the concepts that I talk about in the blog from there. I've prepared uh, a simple application log example, simple observability example in here that I see that it's very common in consulting. We have several customers that um, collect application logs and then derive metrics from those application logs, and also want to provide a search experience to the developers of their applications, right? If a developer, for instance, wants to search for a user or maybe a transaction ID that is inside the logs to inspect what happened in there. That's the typical observability use case for application logs, right? Um, so I will use that. I will use that example and go from there. So we have basically that structure, right? We have a timestamp in here, operation ID, transaction with a user and an amount. Very, very simple example. But we need to understand what's happening behind the scenes when we want to do that at scale, right? Um, in this case, I have a couple logs coming in. It's just fake logs. When we are going to do that in production, we'll have probably millions of log lines uh, per minute, right? Um, so let's understand what happens behind the scenes. So this is the dev tools for Kibana. I'm going to use this. Let's get application logs and understand the mapping um, that is attached to this index, right? We have this message field in there, which is exactly the field that we are visualizing here. It's just a JSON. It's in text format, right? And here, and we are parsing that in our parser that we're not going to cover in here, and we're extracting data from this unstructured data, right? Unstructured message. We're just exposing, right, the transaction.user in here as a field and transaction.amount. And the first problem is right there. Transaction.amount is a text field. You see this little t in here. So why does that happen in first place? So Elasticsearch tries to guess the type of a field based on the first document that arrives at the index. So when this index is created, if we are not careful about the fields, or if we don't know what fields we're going to ingest, we can land in this type of problem that we have amount as text because the first document that arrived at that application happened to be a string with a number inside, right? Elasticsearch will say, well, that's a text field, so I'll apply the defaults. The defaults for a text field is text is having 2 fields actually, one text field and one keyword field. And that's good for data exploration. It gives you flexibility. You just index data in there, and then this data is searchable as just like that, right? We can just type Rick in here, and it will match the message in there in the user because that's part of the string. very good for flexibility, but when we get more and more fields arriving in that index, that will start to become a problem. For instance, let me just stop my ingest in here, and I'm just apply like a mapping to that index, which is a more optimized mapping for that. Message, it's text. I don't want a keyword version of that field. Amount is long, and user is keyword. User is not text. In my case, I don't want full text search. I want the user to be stored in Elasticsearch as a keyword, as a whole token. Right? So a mapping could be this, right? Text and keyword. Let me just recreate my index so we can see what types of mapping arrive in there. Actually, I forgot to put the timestamp in there. That is of type 8. Type 8. Right? Good. By the way, in Kibana, you can just select several commands and just apply them all in sequence, right? Application logs. Let's check if my mapping is in there correctly. Good. Let's start ingesting again. I have a logstash pipeline running that it's just sending data to this index. Okay, so I have it in here. My documents are arriving, but my index have a different mapping now. Let's try to update this. Have a different mapping now. Okay, so you can see that transaction is now a number, which is good. It's what I want. Transaction.user is of type keyword. You can see it in the mapping. Good. However, this is like a minimum mapping for that index. No problem in there. Let me stop my ingest again. Actually, let me add something else in here. So new data is arriving now. Let me refresh this. We'll see a bunch of new fields. So my document structure changed. Someone just decided to add more data to those logs, to the application logs. And now, because I was not careful, I ended up with several new fields inside log data. I have field 1, 2, 3, 4, 5, 6, 7. And then I have 2 new fields for every field because that's default. You see, log data have field 1 type text and keyword. We landed in the same problem as before because I have not predicted that new data was going to arrive. And that's the mapping explosion. This mapping is not exploded right now, but I could have easily reached 1,000 fields, right? If I was not careful. It depends on the data that's arriving. So you want to be careful about that, and that's what the blog is about. The first strategy is being strict. Being strict. So I can control that type guessing that dynamic adding to the mapping with this configuration in there. Dynamic have several options, right? Dynamic strict is the first one. So if I create an index, I'll just create a separate index in there. This index already exists. Let me just recreate it. Dynamic, yeah, never mind. Dynamic strict, good. Let me index a document in there, and let's see what this dynamic strict will do, right? My document, because I have field 3, is rejected. It's saying right here, field 3 is not allowed. The only fields that are allowed are those three fields that are in here. So that's a good approach if you really want to be strict, or if you have a contract with your counterparts that they should only send exactly what is in here. Say if you want to be in absolute control of disk space, for instance, right? That's a strict strategy. Obviously, I can say dynamic strict in any part of my mapping. I can say, for instance, uh, whatever is inside actually transaction, right? Instead of here, what's inside transaction will be strict. All the rest will be accepted. I can do that. And you recreate it, right? And then obviously if field 3 is in here, it will be rejected. But if field 3 is outside, it will be accepted with the defaults, right? Then field 3 was accepted. It's in there, right? Dynamic mapping. Let me get the mapping. The mapping created field 3 as text and keyword. By the way, you can control what type you get by default with dynamic templates. We're not going to cover that, but we have dynamic. That's a subject for another video. All right. So that was the first strategy. You get rejected. You get documents get rejected if they are not if they don't have exactly the fields that are in there. They can have less fields though, right? You can have just only message in there, no problem. Okay, next strategy is to have dynamic false. So I'm going to accept all the fields that you send, the document as is. I'm going to store the source, but I'm only going to index. I'm only going to consider the content of the fields that are specified in there, in the mappings, right? Let's test how this mm, will behave. Let's see. This dynamic mapping disabled, field dynamic mapping disabled. Let's index this with this new field 3, right? Field 4, field 5, let's see, 4, 5 new fields, right? Let's search. Let's actually get first the mappings, that check the mappings. So my mappings are unaltered. Good. I'm not wasting resources on those fields, but those fields are not, only those fields, the new ones, are not indexed, right? However, you can see that the sources are, the documents are here, right? The documents are, it's exactly what I have passed. So I can still search for the mapped fields and see the rest of the fields in the source if I want to. I have some customers that take that approach. They don't want to waste any resources on the extra stuff. They just want to index a couple fields. It's a very good approach actually. And there's a third approach. A third strategy is to use runtime fields. Um, if I create a runtime field, right? What am I going to do here? Dynamic runtime for the extra fields. The extra fields will be searchable, but they will not be indexed. What do I mean by that? Is that all the data structures needed to make those fields searchable will be built at search time. This is why it's called a runtime field. So field 3, 4, and 5 will actually be in a different section. Check it out. Inside mappings, I have runtime. So those fields are actually searchable, and we can make aggregations on them. Let's see. Search, query. Let's add a little bit more space in here. Query. Let's make a wildcard query on the field transaction dot field 4, and the value is, well, hey there, new field, right? Hey star. I just have one document, so let's test actually this in our stream of documents. So let's go back now that we learned this and alter our application logs. Let me just stop my ingest. Okay. Let me alter now the application logs. Logs. It's not in there. Good. Let me alter, saying that it's dynamic runtime. Again, I can put it in here. I can define. I know that I have log data, right? The log data field. I could say only the log data is runtime, for instance. But I have applied now. Let's wait for the data to come in. It's starting to come in with all my fields in there. Let's check the mappings. So the mappings for log data, they are all runtime mappings, and the rest is unaltered. Good. Let me refresh that page. Let's see if we can actually search in log data.field, whatever. So I'll take, I don't know, it's a bunch of fake data. Log data.field 2. So the documents are searchable, right? Even though they are not indexed up front. So you can take that approach to explore your data. And if you decide that a field is used often, right, for searches, you can just decide to actually index that field, and you can change that at the index. It's dynamically, right? So those are the three strategies. I have a very important distinction. If you are using Kibana, you're setting on what I have just did in here, right? You are going to match all the runtime fields in there. It's not really good for performance. You should be doing transaction.field to just something like that. Oh, it's not transaction, sorry, log data. It was log data, yeah. Log data external runtime field, right? And it's matching just that field. How do we do that? Let me stop my ingest again. Actually, I don't need to stop my ingest. It's a dynamic setting, right? I will say that in my settings, Kibana will not match any field, just a group of fields, right? Uh, so I can say put application logs settings, and the default field for queries will be message and maybe transaction.user. Good, I can change that on the fly. And my final mapping like this. You need to be very careful when just leaving the default field will be all fields. Be very careful about that. So you want to limit when using runtime fields. Obviously, you want to limit the amount of fields that you are going to match when using this. So if I just query without specifying a field, you see that the only field that will match is message, because message is in the settings, right? If I want to actually search on a runtime field, that would be I'll have to specify the field log data dot field one is a number, right? 15, yeah, right? It will. Okay. So that was it. You can mix the strategies. For instance, start with the number 2, dynamic false, and then only for specific fields enable runtime fields, right? If you want to do a schema on read for some fields, it's good for exploration. Okay, so I invite you to try that and let me know how it goes. Good luck. Take care. Bye bye.